Leaving cert higher level probability questions with including sets and independent events. In this question, you're told that there's 30 students in a class, 20 study physics, 6 study biology, 4 study both. And you're given this diagram and you're told a student is selected at random from the class. The events E and F are: E is the student studies physics, F is the student studies biology. So by calculating the probability, investigate if events E and F are independent. So let's just fill the information into the diagram first. 4 study both, 20 study physics, which would leave 16 here, 6 study biology, which would leave 2 here. You can see that there's 22 inside, so there's 8 on the outside. So to investigate whether events are independent, if the probability of E multiplied by the probability of F is equal to the probability of E intersection F, we can say that the events are independent. So the probability of E is 20 over 30. The probability of F is 6 over 30. And the probability of E intersection F is 4 over 30. So if you simplify this down, you're going to get 2 over 3. And you're going to get 1 over 5, which is 2 over 15, which is equal to the other side, which is also 2 over 15. Therefore, we can say that these events are independent. This question was asked in 2013. Let's have a look at the 2012 question. In 2012, you were told that the events A and B are such that the probability of A is 0.7, the probability of B is 0.5, and the probability of A intersection B is 0.3. So finding the probability of A intersection B. Sorry, A union B, 0.3 in the middle, which would leave 0.4 in A, 0.2 in B. So the probability of the union is just add them together. 4 and 3 is 7 and 2 is 9. It's equal to 0.9. The probability of A given B is a formula. It's the which we'll look at in more detail at the end of this lesson. The probability of A given B is the probability of A intersection B over the probability of B. The probability of A happening given that B has already happened. So this is equal to 0.3 over 0.5, which is equal to 0.63 over 5. State whether events A and B are independent events. Okay, so let's have a look. The probability of A by the probability of B, is it equal to the probability of A intersection B? Well, the probability of A is 0.7. The probability of B is 0.5. And the probability of A intersection B is 0.3. So you can see here 0.35 is not equal to 0.3. Therefore, these events are not independent. Alternatively, to show events are independent, we could say that the probability of A happening would have to be equal to the probability of A happening given that B has already happened, hence being independent. So the probability of A, jump up with 0.7, and the probability of A given B was 0.6. So again, you can see that these events are not independent. In 2010, there was an independent events question asked as well. You were given this diagram with the intersection already on it, and you were told to complete the Venn diagram. So probability of A is 0.2. There's already 0.15 in there, so that leaves 0.05. We have this one done. The probability of A complement intersection B, well, where does everything that's outside A cross over with B? It's obviously in this sector here. It's another way of saying B less A. So that's 0.6. And then obviously on the outside we're going to have 1. They all add up to 1. So it's like the probability of 2 events happening. Inside we have 0.8. So there's an 80% chance of those events happening. So on the outside it will be 20% or 0.2, which is what question B asks us, 0.2. The conditional probability A given B is the probability of A intersection B over the probability of B, which is 0. A intersection B, 0.15 over the probability of B. These two added together is 0.75, which is 1 over 5, or 0.2, which you can see is the same as the probability of A. So these events are independent. So we can use the A given B part, or we could say if we do it, the probability of A multiplied by the probability of B equals the probability of A intersection B. Probability of A is 0.2. The probability of B is 0.75. Is that equal to 0.15? Well, 20% of 0.75 is 0.15. So you could say, therefore, events are independent. We said earlier that the probability of A given B, so the probability of A happened given that B has already happened, if that's equal to the probability of A, this one, we can say the events are independent. So if we replace that with the probability of A, you can see where the other formula comes from, this one here. So we just cross multiply, and you can see that the probability of A by the probability of B is equal to the probability of A intersection B.